So in this particular session, what we'll be looking at is simple regression equation. Okay, so we have already discussed partial correlation and then multiple correlation earlier on. So if you have not watched that video, please do go back and then watch it. So in this particular topic, what we need to be careful about is that what we've been given is that there is only two variables. Okay, x and y is given. So one is independent variable, one is the dependent variable, right? So whereas in case of multiple regression equation, it is two different variables, two independent variables, and then affecting one dependent variable. Okay. So in this particular question, question number 22 from Kriti publication, statistical methods could be used for MBA, MBS, whatever level you are in, doesn't really matter. So we've been given x and y is given. Okay. So what we've been given is that in the question, I'll just read it out as well. Following table shows the relation between service year and income of worker. Okay, so income of worker and service year. So what will be this thing? So if the service year is greater, your income is getting higher as well, right? So that's basically, so which is a dependent variable then? Your income is a dependent variable on number of service year, right? And then the question has even asked us like if x or if your service year is 12, what would be your income? So see, what the basic thing that we need, we can find out using this equation is we can predict what it might be. If we assume that x is something, then we can predict y as well. So sometimes even we might want to know, right? So if okay, suppose this person is working for this year, how much money we should pay, or like suppose this is the number of beds and then this is your rent, right? So you would want to know that as well. So even you could add different variables to it, like kilometers from train or like the other factors as well. Okay, so multiple equation is used for prediction. Okay, so in this question we've been given this figures over here, right? And then this is number of years, this is in thousands. Okay, it's a figure in thousands, so it's 6,000, 5,000. Okay, it's like that. So what I have done is that I just put in x and y, summation it. So you can do it like you can assume this to be x and this to be y as well, does not really matter. Okay, so then what we need to change is that only this thing, the regression equation will be x on y. Okay, so the dependent variable should be changed from x, from y to x. Okay, that's pretty much it. Otherwise everything is different, everything is same. So x has been added up, y has been added up. All I've done is x into y, and then y square has been done. Okay, x square has been done. Simple table that you already computed so many times, right? In any other equation, any of the other questions as well. So we are finding the regression equation of y or x, right? So we know that the equation is y is equals to a plus byx, which is the slope, and then x, right? That's your first equation. So we know that byx is basically n times summation xy minus summation x times summation y, right? Divided by n times summation x square minus summation x whole square. Okay, so I've just put in the values from here to here, right? And then what I've obtained is 0.6244. Okay, for byx, that's our slope. So in case of A, that's the constant, right? So it is, or that's the intercept, right? And then what I've done is just put in the formula, summation y minus by on x times summation x divided by n. Okay, so in this way I have computed 3.7184. Just simple computation. All you need to remember is what is the regression equation, whether it's on x on y or y on x, then your formula for the slope, formula for the intercept, and now we just put in the values in equation number 1. Okay, in this equation we will put the values. So y is equals to a is 3 point something something 7184, right? 3.7184 plus 0.6244, that's our byx, 0.6244, and that's our x, right? So what this is our equation, okay? So now you can predict. So suppose now you can change the y, okay? So this will be constant throughout the thingy, okay? Throughout the numbers that you're changing, whatever x you change, it will be constant, okay? The equation will be same, okay? It will be pretty much same for until a bit of period, okay? So what you could do is that unless your y has changed significantly, okay? So what we need to do is that we just need to put in the x, right? So the question x asks us if 12 years of service has been done by a particular employee, what would be his salary? So all we need to know, we know that this is the salary, y is the salary, right? It is dependent on x. So every increase in x will increase in y as well, right? So if x is equals to 12, then y is equals to 3.718 plus 0.6244 times 12, okay? So when you multiply this, how much do we get? Let's just use the calculator. 3.718 plus 0.6244 into 12, right? So 11.21. So 11.21. So since this is a figure in thousand, we need to multiply by 1000, okay? So into 1000. So how much are we getting? Is equals to 11,210, okay? So that would be that particular employee's salary, okay? So basically, yeah, this is how we compute. You can change the regression equation from x on y on x, doesn't really matter. Along with that, the formula will also change. All you need to remember is that, and then compute your intercept and your slope, and then basically put in the x, then you will get your answer, okay? So if you have any confusions regarding this kind of question, please do comment down below. We will be definitely working throughout the problem. I will be sending you the solution as well. So yeah, until next time, bye bye.